the objective is to alert you to the connection between what you've learned in this course and other disciplines that to which you have been exposed, and perhaps in the future you'll be exposed to a few more. First of all, the discipline. This word has many meanings, but the one that applies in the university is the following. A discipline is a body of knowledge, a distinct body of knowledge that that has very few rules that underpin great promise, meaning applicability. So that's the reason why thermodynamics is such a body of knowledge. And then I may have told you during the course what the rules are and what the promise is. Thermodynamics is no different when compared with other disciplines. It comes from observations. The observations, meaning a group of observations that, and I'm giving you definitions here, a group of observations that repeat themselves in the same way, innumerably. That group is called one distinct phenomenon. So science comes from identifying phenomenon. One phenomenon after another phenomenon. And then because the human brain is a very small volume, no matter how smart you are, the brain from or during the evolution of the Homo sapiens developed the ability of summarizing these observations into a succinct thought or statement. That statement is called law. That's it. This is the structure of the discipline. In other words, one phenomenon, one law. There may be a few other distinct phenomena, not many. And that means that the book of science is very thin because it contains very few statements. Now, in our case, thermodynamics, with all these parts, we had three parts: the laws, the relations between properties, and then the power applications, has its laws, which came from observations condensed into as three phenomena. So the law, which came from these observations, by the way, I advise you, if you are intrigued by long words, in this case from Greek, reach for the dictionary and check the origins of these words, Greek or Latin most of the time, which populate the English language. English is not a source of let's call it linguistics. It is a fruit basket, and you are empowered by knowing the origin of those words, because they speak of history and they speak of your ancestors. Law. We had the first law, also known as the law of energy conservation, In thermodynamics, it is a remake, a more general version of the law of conservation of energy in mechanics. I would say the common language version of it is that everything that goes up, comes down. You throw the ball upward, and then the ball from up there is driven down by its potential energy and hits your hand with kinetic energy. Shows you that mechanics, very, very old, gave birth to science after Galileo Galilei's questioning of gravitational fall. So up and down and movement has to do with the gravitational pull, or for that matter, gravitational opposition to your effort of lifting. So, but that is the phenomenon, and the first law is the thermodynamics way of accounting for it. But if you know the law, this very, very short statement, you can predict all such observations. You are amazing. There are very few like you. In this case, only 8, for those who are taking my course. The second law, unfortunately, has become the victim of the so-called Tower of Babel. Lots of people have their own version of spelling it out. Well, before you get to the law, what is the phenomenon? The phenomenon is irreversibility. Or the one-way nature of flow. Anything or everything, this is a 2 words. Everything by itself flows from high to low. You see, and you get here the observation that the rainwater flows downhill, that water in your house or piping flows from high pressure to low pressure. Same in everything else, such as the circulatory system in the human body. And then, of course, through the power of the mind to imagine analogies, heat, invisible, flows from hot to cold. So hot versus cold, or high pressure, low pressure, high voltage, low voltage, all these things speak of one way, never the other way around. Key word, flowing by itself, meaning not forced or not impeded by external intervention. Now, in my opinion, there's a third law that has to do with a distinct phenomenon, and that is the occurrence of flow configuration. Not only the occurrence, but from moment to moment, the change in the flow configuration, which is known as evolution. In my next course, I open this idea to the challenge of questioning, because I think that this phenomenon is summarized as the constructor law. Something that was first published in 1996 and has not been refuted by anyone. The point is about empowering you. If you know these very, very simple statements or ideas, then you have the power to predict what is in fact in plain view or observable. And another thing, to predict is called theory. To observe and then describe and then explain is empiricism. And these two things are complete opposites. These two ways of thinking. To predict is to see with the eyes of your mind how something should be and will be, and only later to compare that vision with observations. So there's a time arrow in the thinking process from imagining to checking later. To observe, also known as empiricism, is the opposite time arrow. First the observation, and then that observation through the circuitry of the mind leads to compacting the observation into analogies, similarities, all the way to correlations and coincidences. So the time arrow of predicting is the opposite of the time arrow of describing. And this is very, very important to keep in mind, this dichotomy, a dichotomy that's crystal clear. And it's, of course, irrefutable, but is extremely simple, the simplest, such as the dichotomy between dead and alive, or left and right. I could come up with other examples that are being how should I say, a question today. Anyway, it's very important to know the difference in the fact that there are only two ways. Okay. The course, especially in view of the fact that a lot of it, meaning the mechanics, is not new, meaning thermodynamics is more general. The course is special because of the second law, which before thermodynamics, the second law was completely foreign. Not only the idea, people knew about dissipation, they knew about friction, but they didn't know that that aberration was in fact part of a broader discipline. And of course, the language of thermodynamics became richer with words such as entropy, which were, of course, completely foreign to science. This other thing, the evolutionary design, has to do with older observations, older words, because clearly design is preceded science itself. There were cave paintings before geometry. And today, in my humble opinion, thermodynamics is even better because it's more comprehensive and makes better sense to a common man. That is very different than those who are educated highly and higher, meaning the academics who find themselves at ease exchanging opinions called jargon, meaning opinions that only they understand.